Hello everyone, welcome back. This is a Calculus 3. In this video, we're going to talk about 1.3 polar coordinate system. So this topic will be very familiar with your previous knowledge, such as coordinate points you learned in pre-calculus and previous math courses. So first of all, I want to introduce what the polar coordinate system look like, okay? So let's take a look at the image here. So usually when you have a space, I'm just drawing two space X and Y. Whenever you try to point out and name this point, we just call X comma Y. We call this as a rectangular system, or we call this as a coordinate points. And how to do it? You're gonna find out the unit on the x-axis, and then you're going to find out unit on the y-axis. So this is going to be the distance from the x-axis. This is the distance from on the y-axis. And then by reading those number on x and y, you can find out simply x comma y. Now, I'm going to introduce corresponding system. I'm going to introduce another system that is corresponding to x comma y. We call that is r comma theta polar coordinate system. So in ancient time, they actually didn't know how to read this point in the space. So the ancient mathematician, they actually brilliant in geometry. So they know how to find out the angle. They know how to find out the radius by using the circle, right? So if you think about it, there's a no angle, that means there's a 0 degree, right? And then the more you are increasing this line, you can expand the angle, from 0 to 90, 90 to 100. And then we know that the entire area of the circle is a 360. So by using that system, the angle from the circle and the radius of the circle, they found out another system to find out x comma y, which is a polar coordinate system. So in this section, we're going to describe coordinate system, by Newton, called polar coordinate system. We are not going to use x comma y anymore. We are going to use new corresponding system, r comma theta. So basically you can think about, there are two different systems to read these points. One is coordinate points. Another one is a polar coordinate system. And I will show you how to convert back and forth between two systems. So, if you think about it, so basically here, we're gonna call here 0, 0 is the origin. And then, by reading this right triangle, we can create a circle, right? So inside of the circle, and then this is the center. In the middle, you can find out many infinite number of the triangle, correct? That's what you learn in trigonometry. And then based on the circle characteristic, you can find out two information, the radius, the angle. Okay, so if you can find out the information radius of the circle and theta, that information is going to be corresponding to x comma y in coordinate system. So we are going to call whatever the system that include r comma theta is a polar coordinate system. So I'm going to show you how to convert x comma y into r comma theta polar coordinate system. Okay, and then let's take a look at a couple information. So let me go down slowly. So in this circle, we have like 1, 2, 3, 4. I have 5 different circle in this image, right? And then as you see that, this circle has a center 0, 0. The radius is 1 no matter where you go, right? And then the next circle is the center is 0,0 and the radius is a 2. So I'm just increasing the size of the radius so you can find out infinite number of the circle in the space. What I'm trying to emphasize on, we can find out angle, right? So from whatever the angle on the x-axis, it's a 0. And then if you're going to the counterclockwise, you can find out the positive angle. For example, this amount is a 30-degree, right? And then you can convert to the radian. This is an angle system. This is angle. You can find out the radian by multiply pi over 180. So pi over 6 is the radian, which is the same angle with 30-degree. Okay, so we're gonna use the radian for the angle in the polar coordinate system. And then just I want us to use, the basic concept. What the polar coordinate system is, again, it is the same position. You're gonna find out the same position from x, y, but we are not gonna use x, y. We're gonna use a polar coordinate system in this chapter, okay? So I'm gonna just write a couple things, okay? Just couple identity from the trigonometry that you already learned long time ago. So let me go down slowly. One identity you learn, just this is the recall from the trigonometry because we're gonna use this table a lot. So you remember sine 0 is a 0, sine 30 is a 1/2. So just keep in mind this table, we're gonna use them a lot. I just wanna move on the next slide because I'm gonna write a couple things. So as I mentioned, you can find out infinite number of the right triangle inside of the circle, right? And then the right triangle, it looks like this. And then let's say here I have a theta, the angle. The side that is opposite to angle, we call this is opposite side, correct? And then the longest one, we call this is a hypotenuse. And then the other remaining angle, the remaining leg, we call this is adjacent. So we know the three sides of the right triangle, hypotenuse, opposite, and adjacent. From here, we can find out a couple mathematical identity. Number one, let's say this one we know how to read it. This is the x, y mathematically, because this is the x unit, and then this is the y unit, and then this is how you're gonna read it, x, y, correct? So according to the Pythagorean theorem, we know hypotenuse square equal to opposite side square plus adjacent. Do you guys remember the Pythagorean theorem? So this right triangle is inside of the inside of the circle. So hypotenuse is always the radius. Am I correct? One more time, I have a circle. You have a right triangle. This is a radius. This is a radius. You have infinite number of the right triangle inside of the circle. These are all the same radius. Hypotenuse is always the radius. So radius square equal to, opposite is what? This is the y, right? This is the y square, and then adjacent is x square. So that's why Pythagorean theorem, it means r second power. I can change that order, x second plus y second. And then we can solve for radius by putting the radical on both of sides. So r equal to, cancel, x second plus y second with the radical. So we can find out the first identity from this observation. This is a number one identity we're gonna use. So we are going to convert this x, y to r, theta in the polar coordinate system. And r can be calculated by radical x second plus y second. Does it make sense? So this is all the critical thinking. This is all the story that you already learned. I'm just pointing out one more time. Second observation. Do you guys remember SOHCAHTOA? So in trigonometry, you have a 6 trigonometric functions: sine function, cosine function, tangent function, secant, cosecant, and cotangent. To find out the sine angle, you have S means sine, O means opposite over hypotenuse. So sine angle means this is the angle between opposite and hypotenuse. So this angle indicates the sine angle, correct? What is the cosine angle? This is the angle between adjacent and hypotenuse. Adjacent and hypotenuse, so this is the cosine angle. The last one, tangent angle, which is the angle that is between opposite and adjacent, which is that 90 degree. So SOHCAHTOA just allowed us to find out the sine angle that is between opposite and hypotenuse, cosine angle that is between adjacent and hypotenuse, tangent angle that is between opposite and adjacent, because we have 3 different angles inside of the right triangle. So by using SOHCAHTOA, you can find out sine, cosine, and tangent. So that's what you learn in trigonometry. Why am I using? Because we have a similarity between this trigonometry and polar coordinate system. So from this observation, let's take a look at it. We already know opposite is y, correct? That's a y unit, and adjacent is x. So sine theta, opposite, we know it is y, hypotenuse, that is r. Am I correct? So therefore, you can do the cross multiplication, y equal to r times the sine theta. We found out the second identity. Okay, likewise, I'm going to keep on going. Cosine theta is adjacent over hypotenuse. Adjacent is x, hypotenuse is r. So I can also solve for x. We could do the cross multiplication. X is going to be corresponding to radius times cosine theta. This is the next mathematical identity we found out. Last one, tangent theta, right? So that tangent theta means tangent theta opposite y over adjacent x. So what happened? Just tangent theta is always y over x. We found out the last mathematical identity. We need those 4 identities. So I'm gonna highlight it. So number 1. Actually, I'm gonna make a thicker color. So this is first identity, second identity, third identity, fourth identity. These are really, really, really important component to convert, because we have a specific goal. I want to convert x, y coordinate system to the polar coordinate system r, theta. So we need those 4 identity to convert them. Okay, so a little bit of background. So I'm just reviewed all the trigonometry concept, and we found out some similarity between trigonometry and polar coordinate system. And we just proved a couple identity. We discovered that. Now I'm going to do the real problem, right? So let me go down slowly. I hope you're following what we're discussing here. It's not really complicated. We have a specific goal. I want to convert from basic coordinate points to the polar coordinate system. So let's take a look at the next slide. So this is exactly what we found out. So we call, right, the x, y, this is the basic coordinate system, or we call that as a Cartesian coordinate system. And then we want to convert this Cartesian x, y to the polar coordinate system. They're basically corresponding to each other. They're exactly located in the same position, but one is a Cartesian system, another one is a polar, because the way to find out that position is different. They have a different approach. The x, y, you're simply measure the unit on the x-axis, measure the unit on the y-axis. But polar coordinate, you have to find out the radius of the circle an angle of the right triangle so that you can find out the position that is corresponding to x, y. They're actually talking about the same thing. And then to convert from Cartesian to polar or from polar to Cartesian, we're going to utilize those 4 mathematical identity we just found out one more time. X equal to r times the cosine theta, y is equal to r times the sine theta. Therefore, x, y is corresponding to what? R times the cosine theta, r times the sine theta. And then we found out from the Pythagorean theorem, r is going to be equal to radical x second plus y second. And then the last mathematical identity is a tangent theta is y over x. So I just emphasized those mathematical identity one more time, and let's following the next slide, and let's take a look at the question. So here we go. So I want to really do this problem. So what's going on? We have rectangular. So there's a couple name. So let me write it. Rectangular point means the same as Cartesian coordinate system. This means the same as x, y system. So rectangular coordinate, Cartesian coordinate, they're same meaning depending on the textbook. They're indicating the points that is represented by x, y. We want to convert this to the polar coordinate system r, theta. So I have 1, 1. So we have 1, 1. We know how to find out the point. 1, 1 is right there. This is x, y. And 1, 1. I want to convert this one, r, theta, polar coordinate system, right? So x is a given, y is a given. Am I following? Yes. So we have a couple information since x is a 1, y is a 1. We can find out the r because r is the same as x squared, y squared with the radical according to the mathematical identity we just proved it. So therefore, we can find out what the r, which means 1 squared plus 1 squared, radical 2 is the radius, right? Okay, so we found out the r is a radical 2. Can we find out the theta? So since x and y is a given, if you're using the tangent theta, y over x is going to give you what the tangent theta. So tangent theta, since we know tangent theta is y over x, it's going to be 1 over 1, 1, which means the tangent theta is 1. Can we find out the angle? Go up the table. Tangent, we found out the 1 when 45 degree with tangent, that is 1. So therefore, we found out theta is a 45 degree. As a radian, we can convert it by multiplying pi over 180. So pi over 4, that's the radian. That's the angle. So pi over 4, we found out the theta. So what does it mean? 1, 1, this is the Cartesian rectangular point. It is the same as radical 2, pi over 2, pi over 4. In the polar coordinate system, they are same. So they're indicating the same position in that space. Okay, so that's how you're converting from rectangular to polar. Does it make sense to you? So 1.3, it's not really complicated concept. It's a very understandable topic because we are using all the previous knowledge from the trigonometry. Okay, so take a look at it. That's how you're converted. We're gonna practice a couple more. I'm gonna go down, make a space. Let's do the letter B, 0.3. So I'm gonna bring here, change the color. 0.3, this is x, y. I want to convert it to r, theta in polar coordinate system. So you can find out the r. By the way, I'm going to highlight this because we use the mathematical identity. So we know that since we know x equal to 0, y equal to 3, we can find out the r, x second, y second with the radical. So 0 square, 3 square, that is a radical 9. Gotcha, this is going to be 3. So r is going to be 3. We just found out. Can we find out the angle? So since we know x and y, I'm going to use a tangent theta. So tangent theta is a y over x. So it is going to be 3 over 0. Whoa, 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 whoa. If you divide it by 0, it's undefined. So if you have undefined, which angle give you the undefined with the tangent? Go up, 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 up. So tangent 90 or tangent to 70, both angles gonna give you the undefined. So 90 degree, we know exactly here. And then 270, so 90, 180, it's bottom. But as you know, 0.3 is on the positive angle. So we have theta has a 2 angle, 90 and 270. You can convert this one as a radian, pi over 2. This one is going to be, I guess, if you multiply, it's going to be 3 pi over 2. But we know that 0.3 is right there. So therefore, this is not the bottom. 270 is here. So the answer is going to be 90 pi over 2. So the answer is pi over 2 as a radian. So what happened? We found out the radius 3. We found out the angle pi over 2. So that is a corresponding answer with 0.3. So 0.3, one more time. This is the Cartesian. So what does it mean? The polar coordinate system. The radius is a 3, right? So the radius is going to be 3 and the angle is going to be pi over 2. So that's the same corresponding, polar coordinate system that, with the 0.3 in Cartesian system. So that's what it is. We can convert it to each other and then they exactly indicate the same location, right? Same thing above 1.1 and radical 2, pi over 4. That means they are located in the same position, just different perspective. Okay, so it's getting better. One more example, letter D. How about letter D? So let's take a look at letter D. I'm gonna change the color again because that's a D. So this one, sorry, this one was a B. Actually, we are doing C. So 5 radical 3, negative 5. So this is x, y. I want to convert it to all theta. Step by step, let's find out the radius, right? So this is x, this is a y. So r is going to be x second plus y second. So that means 5 radical 3 to the second minus 5 to the second. So therefore, if you calculate it, this one you multiply twice. So 5 radical 3 times the 5 radical 3. Right? So this is a 25. This is going to be 3, 75, and negative 5, 25. So which means radical 100. Gotcha. 10. The radius is a 10. So the circle, the radius has a 10. Now we want to find out the angle. So tangent theta, y over x. Y is negative 5. X is a 5 radical 3. So we have negative 5 over, we can cancel it. 5, 5 cancel, negative 1 over radical 3. So if you simplify, you can multiply radical 3 top and bottom. It is the same as radical 3 over 3. So tangent theta is negative 3 over 3. Am I correct? So let's go to the table. Which angle gives you negative radical 3 over 3? So this one is a corresponding. This is the same as the radical 3 over 3, but it's a positive, but we have a negative. It's going to be negative 30 degree. So the theta is going to be negative 30 degree because, and I can change it to the radian. So as a radian, you can multiply pi over 180. That's how you convert from the angle degree to radian, it's going to be negative pi over 6. So what happened? The radius, this is corresponding to 10 comma negative pi over 6. Those are 2 points are located in the same position. Okay, so one is a Cartesian rectangular, just basic coordinate points. And then another one is in polar coordinate system, just they have a different approach. This is we are using the circle's characteristic in the polar coordinate system. In the Cartesian, we're just using the basic, unit on x and y axis. Okay, so that's what it is, polar coordinate system. I introduced what they mean, where it came from, and you got it, how to convert from the Cartesian to the polar. Now we are going to do the similar work, a little bit of backward. Let's take a look at the next question, okay? Okay, now I am going to give you polar, and I want to convert it to x comma y rectangular. So we are going to do the backward. So polar is given, you're going to convert it to the x comma y. The previous question, right? We had an x comma y, and you convert it to the r comma theta. So we're going to do the backward. It's going to be same work. So now we're going to use another mathematical identity we discovered. So go up. We're going to use this too. So we have 1, 2, 3, 4 identity. Those are two going to help us to convert from polar to Cartesian. So let me write it. So we know x is equal to, we prove that r times cosine theta, y is equal to r times sine theta. So this is going to be helpful note. So therefore, what happened? We're going to do convert. This is r, this is a theta. So x is going to be r times cosine theta. So r is already given 3. And then times cosine theta is pi over 3. You can just calculate them. So that means 3 times cosine pi over 3 is 60. Okay, so what does it mean? You're going to find out what the cosine 60, go, the table. Cosine 60 is going to be 1 over 2. So you can 3 times 1 over 2, 3 over 2, that's the x. So I'm going to minimize it. So 3 over 2 is going to be the x that is corresponding to the radius r in the polar coordinate system. Likewise, we're going to find out the y, r times sine theta. So 3 times the sine pi over 3. So 3 times the sine 60. So you can find out what the sine 60 go up. It's going to be 3 radical 3 over 2. So 3 radical 3 over 2, that is y. So what happened? 3 over 2, comma, 3 radical 3 over 2. This is the corresponding to 3 comma pi over 3. So if you remember, if I point out this position, we have a 1, 2, 3 radius. So we have a circle, the radius is a 3, right? And then pi over 3 is going to be 60 degree. So this is the position 3 comma pi over 3. As a Cartesian polar coordinate system, 3 over 2 comma 3 and radical 3 over 2 is a corresponding. They're located the same position. That's what they mean. Okay. So let's take a look at just one more. I think it's a very simple question, but let's take a look at one more. This one. So this is r and theta. So we want to convert it to x comma y. So x is going to be r times cosine theta. So r is a 2 cosine 3 pi over 2, right? So if you don't know what the cosine 3 pi over 2, you can actually use a decimal. Just go to decimal, enter cosine 3 pi over 2. That is going to be 0. Okay, so x is going to be 0, y, r times the sine theta, 2 times the sine 3 pi over 2. If you don't know what that number, go to decimal. That you can use either table, trigonometry table, or you can use a decimal, that's okay. So sine 3 pi over 2, that's actually going to give you -1. So 2 comma -1. So what happened? It is corresponding to 0 comma -2. So this one, you can think about it. Okay. 2 is going to be the radius, is a 2. So in that circle, 3 pi over 2, if I just want to find out the angle, I'm going to multiply 180 over pi. So this is 270, exactly this is the angle. So this is the 2,3 pi over 2 as a polar coordinate system. Exactly this is corresponding to 0, x is a 0, y is a -2. It's corresponding, and then they're located in the same position, as you can see that. Does it make sense to you? So think about it. It's not really challenging question at all. We are just using mathematical identity and convert back and forth between Cartesian to polar or from polar to Cartesian. Okay. So I'm going to skip this one. You can try this yourself. Try it. I think you can make it. Okay. I'm going to do one more example. Okay. So let's take a look at one more example. Okay. We are going to find polar coordinate. So this is going to be x, y. Let's convert it to r comma theta with the given rectangular points, and radius should be positive number. So we know we can convert it to, Cartesian or rectangular to polar. So the step 1, r is, we know, x squared plus y squared. So therefore, we can plugging in -a to the second, positive a to the second. So 64 plus 64, that is 128, correct? Again, this means actually 64 times 2 with the radical, that is going to be 8, and 2 is going to be inside of the radical. So r is going to be 8 radical 2. Next one, tangent theta is y over x. Y is 8, x is -8. So we have a tangent theta is -1. Am I correct? So how to find out the theta? Do we have in the table? So let me check it out. Tangent theta is 1. So maybe, right, -45 could be the possible answer. Okay. So the theta, -45, you can convert it to the radian. So 45 divided by 180, if I divide it by 9, so this is going to be 9. Actually, if I divide it by 9, it's going to be -5. This is going to be 20. I can also divide it one more time. So let me just double check in my calculation. 180. It's going to be 4, right? So it's going to be -1 over 4 pi. Okay. So you can find out the radian like that. So they're indicating the same position. Okay. So think about it. It's not really challenging question at all. So you can wrap up this concept. Now I'm going to move on to the second topic. Okay. So far we talked about how to convert back and forth. One more thing we need to know. So one thing I want to share, the core angle, the characteristic of the polar coordinate system. So one thing is, this is going to be very interesting. So just remember, negative r comma theta is going to be the same as r comma theta plus pi. I will show you what they mean by looking at the following example. So let's take a look at the example. This is all the polar coordinate system. Okay, so this means r is 1, theta is 5 pi over 4. I want to point out where this r comma theta is located. So in the circle, okay, the radius is 1, and then you can find out the 5 pi over 5 as a degree. So if you multiply 180 over pi, what are you guys gonna get? Let me calculate it. 5 times 180 and divided by 4. This is a 225 degree, 225 degree. So it is going to be somewhere here. So the radius is going to be 1, and then the angle is going to be 2 to 5. So this is the location where 1,5 pi over 4 in the polar coordinate system. Does it make sense to you? What that means is you can find out the symmetry here. This is going to be symmetry. If you want to find out the symmetry, this formula is going to be work. So the radius is 1. This is r comma theta. So the opposite radius is going to be r comma theta plus pi, or theta minus pi, because this is a 180 degree. 180 degree as a radian is a pi. So this position is going to be -1 comma, you can subtract 5 pi over 4, or this one minus 180. So you can subtract pi. So 4 pi over 4, it is going to be pi over 4. So this is the, we call like a, co-symmetry angle. So I'm going to write it co-symmetry angle. So that's why r comma theta, if it is here, the opposite side is going to be -r, and then theta plus pi. So this is not correct. So this is your angle because you're moving 180 degrees. So you can find out all the co-symmetry angle from the given example. So I will do a couple example. So next one, 2,3 pi. So let me take a look at the next question. I need a more space. So what do you think? 2,3 pi. The r is radius is a 2, theta is a 3 pi. So in the circle, the radius is 2, and 3 pi, if you convert it to the degree, 3 pi, and then you multiply 180 over pi, it is going to be, it's a big angle, 500, right? 180 times 3, 540 degree. So you actually, the entire circle is a 360. If you subtract, you have to go to 180 degree to go more. So you start from here with the radius, you go up, this is 360. From here, you're gonna go to 180 more. So this is the location, 2,3 pi. Am I correct? You can find out the co-symmetry angle right there, which is here. -2, you can subtract pi, or you can adding pi. Doesn't matter. They're locating the same opposite side. So -2 to pi, exactly. This is 360. So they are co-symmetry angle. You can find out. Okay. So I don't want to emphasize on this type of question too much, because this is just one characteristic in terms of the polar coordinate system. Actually, I want to do more important question in the next slide. So I hope you guys understand what the, this two equation means. You can find out the co-symmetry angle. So you can try those two. It's not really complicated. Just find out, locate it, where they are, okay, where they are in the space, and then find out the co-symmetry angle by using the formula. So try those two examples. Should be very, very okay, okay? So what I'm gonna do, I'm gonna explain the next one, the next topic, polar curve. This is the very important topic. So far, if you guys remember, we were able to, find out the function by looking at the x comma y. So let's take a look at this one. So now we know how to plot points in the polar coordinate system so that we can discuss how to plot curves. So what I'm saying is, in the rectangular coordinate system, you were able to graph a function y equal to f of x, because as long as you know x comma y, you're gonna plugging in the input x, you were able to find out the output so that you were able to create a curve. You can create the graph of the rectangular function, correct? In similar fashion, we are going to graph the polar r equal to, it is going to be f theta. Now your theta is going to be the input, your radius is going to be output. So we are going to learn how to graph the polar function, how to graph the polar curve in this topic. Does it make sense to you? So these are the strategy, but I don't want to really emphasize on the strategy because I want to use the example so that you can understand better. Okay, so the general idea behind graphing a function in polar coordinate system, it's the same. It's the same as graphing a function in a rectangular coordinate system. Okay, so let's take a look at the following example so that you can actually make a graph of the polar coordinate system. So let's take a look at the next one. So here is the thing. If you remember, I'm going to give you, like, let's say I'm giving you y equal to x plus 1. Everybody know how to graph it because this is a linear, right? The y-intercept is 1, slope is invisible 1. So you are passing to the y-intercept. It is a positive. So everybody know how to graph the rectangular x comma y system. I want to graph this one. R equal to 4 times the sine theta. This is polar coordinate system because it has r comma theta. How would you be able to plot all polar coordinate system and how to graph it? So here we're going to use a couple mathematical identity. It's not that complicated, okay? We're going to use a couple mathematical identity you already learned. First of all, what is the equation? R equal to 4 times the sine theta. We know theta is the input, R is going to be your output, but I don't know how to graph it, right? Because it's not simple like x comma y. It is angle and radius. So first step, you're going to multiply R on both of sides. So let's observe what's happening. So then it is going to be R squared. And then you're going to get 4 times R times the sine theta. Because I'm just simply multiply R on both sides. Now, let's keep going. What mathematical identity do you know? We know R second is x second plus y second from the Pythagorean theorem. And what else do you know? If you remember, go up, all the way up. These identity. X is R times cosine theta, Y is R times the sine theta. So we know couple identity, Y equal to R times sine theta, X is equal to R times the cosine theta. We know a couple mathematical identities. So what happened? R second, I can rewrite it as X second plus Y second. And I see R times the sine theta, ooh, that is going to be Y, so equal to 4 times Y. Are you following? So I don't know how to graph based on R comma theta. I know how to graph based on X comma Y. So we are going to convert this polar coordinate equation. This is a polar coordinate equation. I'm going to convert it to the rectangular function just based on X comma Y. So now it means X second plus, I'm going to move this one to the other side. So then it is going to be minus 4y plus y second equal to 0. It looks like it is a quadratic function. I'm going to make it more beautifully, write it. So we are going to x second minus 4y, right? And then to find out the, nice quadratic function, here you're going to do find out the factor. I'm just making a little bit of space and just make it smaller, equal to 0. So what I'm saying is if you are adding, subtracting, whatever the same number, plus minus, this does not cause any change in this equation. So one strategy is you have a coefficient -4 in front of the y variable. So you can do -4 divided by 2, half of it, and square. So that is going to be 4. So I'm going to adding 4 minus 4. But what I'm saying is it's anyway 0. So this does not cause any changes in this balance. So the reason why I did, because I want to see the 3 terms, that is going to be x minus 2 second power. X second plus y second, sorry, minus 4y plus 4. They are going to be the simply factor out x minus, right? Oh, actually, I have a mistake here. We have to combining the same y. So let me redo it again. I'm so sorry. Oopsie, oopsie, oopsie. So let me just get rid of it. Oh, no. Okay, one more time. So I'm going to rewrite it. This one means I'm going to change that order. So x second, and then we have a y second minus 4y. And then if I adding and subtract any number that is balance is 0, it does not change anything. Are you following? This is better. So to find out the number, so this is what? -4 divided by 2 half, which is a 4. So you are adding 4 minus 4. Those are 3, right? Y second minus 4y plus 4. That's the same as, so we can rewrite it. This is the same as x second, y minus 2 second. That's the corresponding, and we have a -4 equal to 0, which means x second, y minus 2 second equal to 4. Wow, what happened? We just convert this polar coordinate equation, the polar function, into the rectangular equation, which is x second plus y minus 2 to the second minus 4. So they converted from here, we converted to this one, because I don't know how to graph the polar, but I do know how to graph the rectangular. So what does it mean? This is a circle function. At center, 0,2 with the radius is 2. So we can graph it. So let me minimize it. Right? So we can graph it. This function, if you actually graph, the center is a 0,2 right there. Right? So let me minimize it. And then from here, you go the radius. This is the center, 1, 2. Everywhere you go to 2. So this is the circle. This is the graph of r equal to 4 times the sine theta. What we just did it? We just converted to the rectangular, because I don't know how to read and how to graph this rectangular function. So therefore, the 4 times the sine theta in polar coordinate function, it is going to be this graph. The radius is a 4, and the center is a 0,2. Okay, so if you literally input any angle and output, they're going to be in this circle. Are we okay? So this is something we're talking about, the polar curve. I want to find out the polar curve and I want to graph it. The step is convert what are you going to convert? Convert polar function to rectangular function, because a rectangular function is much easier to graph it. So as you see that, by using the mathematical identity, you can convert it to the rectangular function, and that's much easier to graph the polar coordinate system. Are you okay with that? Awesome. So we're gonna practice a couple things here. I'm gonna do letter A, B, C, D. So let's do all this question. Are you ready, ready? So letter A. So we have a polar coordinate function given, we want to graph it. So they want to convert to the Cartesian equation so we can graph it. Or you can just find out the equation that should be enough. So we have r equal to 2 sine theta. I do know we're going to multiply r on both of sides. So that is going to be r second to r sine theta. As you know, r second, r times the sine theta, we can convert it to the x second plus y second. This is the same as x second plus y second. And r times the sine theta, that is y. So that means x second plus y second minus 2y equal to 0, correct? I'm going to find out, the nice function. So x second, y second minus 2y, and you're going to adding and subtract some number. How to find out that number? You have a coefficient divided by 2 and square, that would be 1. So you're adding 1 minus 1. It's anyway 0, does not change any, you don't have any impact on this balance. So therefore, y second minus 2y plus y, that's my factor. So we can rewrite it. X second, y minus 1 to the second. That is the, if you expanded it, that's y second minus 2y plus 1. And then we have a negative 1 equal to 0. So if I rewrite it, x second plus y minus 1 second equal to 1. So this is going to be circle function. Center where at 0, 1 and radius is 1. So if I graph it, you have a center 0, 1 right there. This is the center. Go up 1, go down 1, up, right and left. So this is the circle. Okay, so this is the graph of r equal to 2 sine theta. Very tiny circle at center is 0, 1. Okay, so you are getting better and better. So you can, so there's a limit. Polar, if you have only polar equation, it's hard to graph it. This is hard to graph. If you convert to the Cartesian, this is easy to graph. So that's why we are converted from polar to Cartesian equation. So let's do letter B, another example. So I'm going to do here B. So same thing, r equal to 9 times cosine theta. You're going to multiply r both of sides. So r second, 9r cosine theta. So we know this is x second, y second, and then 9 times y. Again, that means x second, y second minus 9y equal to 0. Nothing is something new. Everything is similar what we did. You're going to find out the number to find out the same balance. So to find out that number, you're going to half of it and square, correct? So that is going to be 81 over 4. So you have 81 plus subtract 81 over 4. So that would be, if I rewrite it, x second, y second, negative 9y plus 81 over 4 minus 81 over 4 equal to 0. Why? Because these three terms are going to be factored out. Y minus 9 over 2 to the second power. They're going to be same. Right? So therefore, x second and then minus 81 over 4 equal to 0. So that means, if I write it better, equal to 81 over 4. Again, this is a circle. Circle center at 0, 9 over 2. Radius is going to be, what do you guys think? The radius is going to be 9 over 2 because according to the circle equation, x second, y second is r second. So this one is a radius second. So radius itself is 9 over 2. Same thing, we just did it. The radius is a 1 square. It's a r square. So r radius itself is 1. Same thing you did it here. Radius square is 4, radius itself is going to be 2. That's how you read the circle equation, right? So how you can graph it. So 0, this is a 4.5. So from here, the radius is 4.5 again, 4.5 again, 4.5 again, 4.5 again. This is going to be the circle. And that's the graph. This is the graph approximately r equal to 9 cosine theta. Are you happy with that? You made it, okay? I'm gonna do couple more. Let's do letter C. I'm gonna make a space. So C here, let me change the color. So C is what? R equal to 6 cosine theta minus 8 times the sine theta. Oh, this is a polar. It's hard to graph it. I'm going to convert it to the rectangular by using a couple mathematical identity. So what happened? You're going to multiply R anyway on both of sides. So that would be now, what happened? You have R second. So if you multiply R and R here, 6R cosine theta, 8R sine theta. And we know that R cosine theta, R sine theta, R squared, we can use a mathematical identity. This is x second plus y second. R cosine theta is a 6x. R sine theta is 8y. So I'm going to rewrite it. X second, I'm going to move a 6x and 8y to the other side. So negative 6x plus y second positive 8y equal to 0. So here, we're going to use the same strategy here. X second minus 6x plus and minus same number. Y second plus 8y plus minus the same number. You're going to do it. So let me minimize it, equal to 0. So how to find out that number? So here, coefficient divided by 2 square, which is a 9. You are adding 9, subtract 9. It's the same 0, doesn't matter. The second one, 8 divided by 2 and then square, which is a 4 times the square, 16. You are adding 16 minus the 16. It's anyway 0. Why am I doing this? X second minus the 6x plus 9. Y second plus 8y plus 16. You can find out the factor form. So that is going to be x minus 3 to the second minus 9, y plus 4 to the second minus 16 equal to 0. They're corresponding. This is a corresponding. This is going to be corresponding. So we can find out the circle equation. So x minus 3 second, y plus 4 second. So negative 9, negative 16. I'm going to move to the other side. They're going to be 25. Exactly, this is a circle equation. So this is a circle. Center at 3, negative 4, and radius is 5. So if you graph it, this is now you can graph it. So 3, negative 4 right there. So from here, you're going to move up 5. You're going to move up 5. You're going to move up 5 down. So this is going to be the circle. So that's the polar. This is the graph of r equal to 6 cosine theta minus 8 sine theta. We just graph it. Again, it's hard to graph with the polar coordinate function. You're going to convert it to the Cartesian rectangular function so that it's much easier to graph it. Okay, so let's take a look at 2 more, D and it. I'm going to help you guys. So I hope this practice is really, really helpful. Let's do D again. So I'm going to make a space here, D. Okay, so D is r equal to 5 times a secant theta. Oh, this is a secant theta. So for your recall, according to the trigonometric concept, we know sine theta is 1 over cosecant theta reciprocal. Cosine theta is 1 over secant theta. Tangent theta is 1 over cotangent theta. In other words, cosecant theta is 1 over sine theta. Secant theta is 1 over cosine theta. And then cotangent theta means 1 over tangent theta. So you already learned this trigonometry identity in long time ago. So we're going to convert to the Cartesian equation. So what are you guys going to do? That means because this is secant theta is bugging me. So that is the same as r equal to 5 times secant is what? 1 over cosine theta, because cosine sounds more comfortable. Now that means r equal to 5 over cosine theta. Can we do the cross multiplication? So r over 1. You're going to do the cross product, cross multiplication, so that 5 equal to r times cosine theta. Are you following? So what do we know? R times cosine theta, that means we know x. So simply we found out the equation. This polar equation is going to be corresponding to x equal to 5. In the Cartesian equation, how to graph it? This is just going to be vertical. So if you have x equal to 5, this is a vertical line passing through 5. X equal to 5, 1, 2, 3, 4, 5. This is the graph. This is r equal to 5 times the secant theta graph. So in this graph, you have just vertical line. It's not circle. So we never know what kind of graph you're going to get, but in this time, we got the vertical angle. So that's the graph of this polar function. Okay? So nothing is difficult. You can do this. All right? One more example I think we have. So let me just go down. We have an A, B, C, D. Let's do the last one. So here, the E, we have r equal to secant theta plus tangent theta. So here, I'm going to convert whatever I do now. Actually, my bad. It's not more addition. It's a multiplication. So secant theta, we just know it is a 1 over cosine theta. Tangent theta, we know it is the same as a sine theta over cosine theta. We are multiplying, that is r. So what happened? R equal to sine theta over cosine secant theta. You can now do the cross multiplication. So r times cosine secant theta is a sine theta. Am I following? From here, we just keep using the mathematical identity. Let's multiply r on both of sides. So r squared cosine secant theta, it is going to be r times sine theta. Are we okay? That means r times cosine theta entire second, and then r times sine theta. We know everything. What happened? R cosine theta is going to be what? X second power. R sine theta, that means y. So we have y equal to x second. This is a Cartesian equation. So when you graph this polar, they're going to be create this shape. So this is r secant theta tangent theta graph, which is corresponding to the simple quadratic function. Okay, so far I show you a lot of information. I hope that is not complicated. So we begin with the polar coordinate systems definition, what that is, and how to convert it to the Cartesian and back and forth, and also how to graph it. The graph, the drawing graph, you need to convert it to the Cartesian, because of polar, it's complicated to graph it. So you're going to convert it to the rectangular, so that it's much easier to make to graph it. So now the next one is going to be short topic. So we have many polar curve in this topic. So one of the examples, you're going to find out many polar curve that is related to r comma theta. So I'm going to show you a couple things. So you see that there will be a lot of polar functions. So I'm going to talk about the polar functions. There are a lot. One of the polar function is a cardioid. I'm going to show you everything actually. So cardioid, if you remember, they have R and theta, correct? So R equal to whatever number times 1 plus minus a sine theta, or R equal to constant times 1 plus minus cosine. These are, we call this, cardioid, shape, or it's a part of the polar function. It's hard to graph it, okay? And then also it's going to be complicated to convert it to the rectangular because we have, more like a distributed property. So I'm going to show you a little bit of organized work. I'm going to show you a couple, unique polar functions. So one is a cardioid, and then I will show you rows of pattern and other pattern. So we can actually use a decimal. Okay, so I'm going to go to decimal quickly. Where is it? So here. Okay, so you can actually find out whatever the points. So I'm going to create a table. So we have, let's say we have, or you can simply, you can simply enter R equal to, what was the equation? Let's say we have a 2 plus 2 times cosine and theta. Okay, so you see that? This is not the circle. This is not like a quadratic. It looks like a heart shape. You see that? So when you have the function R equal to constant times, plus minus constant cosine or sine, they're going to create a heart shape. We call this as a cardioid. Looks like a heart shape. So that's why I'm going to go back. So this is a unique function. If you have R equal to some constant plus minus constant sine theta, or constant plus minus constant times the cosine theta, they're going to create a heart shape as a graph. We call this two function as a cardioid function as a part of the polar function. So you don't need to fill out this information because we can use a decimal. You can easily check what the shape looked like. So the shape, if you draw, so it was a shape, heart shape. Okay, so remember, cardioid, it's a part of the polar function. And then when you graph it, they're going to create the heart shape. And then the function of the cardioid is R equal to A plus minus A times the sine theta or cosine theta. So likewise, I can show you more. How about this one? What if you have R times phi times the sine 3 theta? So let's go to decimal, back to decimal. So I'm going to get rid of it. So we have R equal to 5 times the sine, and we have a 3 theta. You see that? So what do you like? It looks like a rose or rose or leaf. So if you have simply, A times the sine B theta, you're always going to find out the rose pattern. So I'm going to go back. So you don't need to really memorize anything. I will show you all the organized tables. So what I'm saying is R equal to number times B theta, it is going to be the rose pattern. Especially when B is odd number, you have the same number of petal. Number of B petals. If your B is even number, you're gonna have the number of petals is going to be 2 times double. So what I'm saying is, here we had a 3. This is your B equal to 3. So therefore you found out the 3 petals because the 3 was odd number. If I have a 4, am I going to have a 4 petal? No. 4 times a double, you're gonna find out the 8 petals because it is even number. So let's check one more time. Here, you see that I had a B equal to 3, so you have a 3 petal. But what if I have R equal to 5 times, let's say sine 4 in this time, 4 theta. What do you guys think? We have a 1, 2, 3, 4, 5, 6, 7, 8 petals. Because 4 is an even number, you're gonna have a double petal. So that's the rose shape. So I'm showing you 2 unique polar function. One is a cardioid shape, another one is a petal, the rose shape. And the function is gonna be like that. These are the function. So there are a lot of unique polar function, not only cardioid or rose shape. So here are all the unique shape you can see. If you have a polar equation is very important. If you have like a theta equal to k or r equal to this combination, r equal to a plus b theta, or this is all the cardioid, we just talk about it. Or if you have r equal to a times the cosine theta plus b, or the other sign, and the rows, you're gonna have a very unique patterns of the graph. So in this 1.3, I'm just emphasizing on the cardioid shape, which is this function. This is all the polar equation. And the rows, these are the unique, because the shape is a heart, the shape is gonna be like a petal, rows. So again, like a rose is a little bit unique. Depending on the B, whether it is even or odd, you're gonna have the same number of the petal or double petals. So that's what I show you in the previous 2 example. And then these are all the possible polar equation you can see in our textbook, but I'm just emphasizing on the cardioid and rose. It's a very unique, isn't it? Because this equation is based on r comma theta. Okay, and then it's hard to graph it based on x comma y. So this is already organized and give it to you so you can think about it. Okay, so one thing, actually I already mentioned that. So the cardioid and rose is very unique. So rose, one more time, this is the equation of the rose polar function. Again, if it's sine, cosine, you can have a sine and cosine. If b, right, the k, the b spot, if it is odd, you're gonna have the same number of the petal like a B. But if a B is even, you're gonna have a 2 times B petal. So I want you guys just explore, just use a decimal. So the sine, cosine, these are the rows, polar function. You can actually graph it and check. So let's check it out. I'm gonna go back to the decimal. So my function was, what was it? I'm gonna go to the next one here. So the function was here, r equal to cosine, and I do have a 2 theta. So you see that this is the rows, and 2 is even, but the number of the petal is a 4 because it's a double, correct? One more time, we have r equal to, okay, r equal to, let's say in this time sine, doesn't matter, sine and cosine, sine, but I'm gonna use the even number, 3 or 5. 3 theta. What do you guys think? We have exactly 3 petals. So you can graph it. So one more time, this is the double, this is a double, and that is, 3. So we can go back. So you can play with the decimal, just play with all the cardioid function, you can play with the rows function, and then check it out, what does the shape look like? So here we found out we have like 1, 2, 3, 4 petal. Here's a 3, so you have a 1, 2, 3 petals, because it should be double. 2 is even, so you have a 4 petals, and then 3 is odd, you have exactly same number of the petals. So that's all the polar function that is a very unique shape. So that I just want to emphasize on that, so you can find out more interesting, information. So this 1.3, yes, we finished all the polar coordinate system. So go back to the, the first slide, what the, polar coordinate system mean, and then how to convert, how to graph it, and then how to find out, understand the unique shape of the polar function. So that's all about it. Thank you for listening, everyone. You guys are awesome. So if you have any question, feel free to post in our discussion board. It's a very engaging and very active space. You can, ask and help each other. And if you understand the concept, go ahead, 1.3 quiz. There are more embedded video you can watch. So you can build up a better confidence as well. If you have any question, you can email me as well. I will stop here and I will see you guys in the next video. Thank you, everyone. Bye-bye.